Hey guys, this is Dawson, and this is a video about the physics behind the largest rope swing in the world video. There's a link to that in the description. So I wrote a program in VPython about the rope swing and modeling the motion. But first, here's a few calculations. So, at the bottom of the rope swing, all the gravitational potential is going to kinetic energy, so you can use this formula and get the velocity. And these are all kind of rough estimates of what the numbers probably were. About 150 meters for the rope and about 90 kilograms for the person. And using the centripetal force formula that I have here and the free body diagram, we can see that the only force acting upwards is tension and down is gravity. So we can see that mv squared over r is going to equal the tension minus gravity. So using that, we can find the tension. And we end up getting 2645 newtons for the tension at the bottom of the rope swing. Now at 30 degrees, we can see that the height, it's only going down 150 times cosine of 30 instead of the whole 150 because it's only a 30-degree angle from where it started at. And so we can use the same formula from before, mgh equals 1/2 mv squared, and get the velocity to be 50.45 meters per second. Just kind of slower than before, but we're not quite at the bottom of the swing yet, so the velocity is supposed to be a little bit less. And then calculate the tension at this point in the rope swing. You can use the same formula, but instead of using just mg, we're going to use mg cosine of 30, because we're trying to find it in the y direction, because that's the easiest way to calculate it. So we can see that centripetal force is going to be tension minus mg cosine of 30, and we get the tension to be 2291 newtons, which is less than before, so we can see that these calculations kind of show an estimate of how much it actually would be. And then at the bottom, calculating it as a spring instead of just a rope with like no stretch at all, we can calculate the amount of stretch that it's going to have. So we know that the tension is already going to be this number at the bottom of the swing, and instead of tension force, we can say that the spring force is pointed up. And so spring force is Ks and gravity is mg, so using this we can find that the stretch is going to be about 2 meters. And then same thing over here for at 30 degrees, we can see that the stretch is going to be about 1.79 meters. So it stretches out more at the bottom, there's more force at the bottom, and it's moving faster at the bottom, so yeah, that's a rough estimate of what it's supposed to be. And moving on to my program, you can see here I have all of my constants defined, where the rope starts at, the start position, all the stuff for calculating the force of air friction and whatnot. Here are all my objects defined. I have my arrows commented out right now because I'm just showing a quick demonstration. And so here I have gravity defined up at the top, and then I have spring force defined here, air density, force of air, then I have my F net. So this is my, sorry for the quality, this is just recorded on my phone, but this is my demonstration. So as you can see, this is the graph of the velocity. So the velocity is definitely the highest at the bottom point of the rope swing. And so you can see that calculation was kind of close. It's about 49 meters per second. So yeah, that's about all.